Hi guys, so this video is on the law of cosines. So we had studied the law of sines, so now this one's about cosines. So I'm going to start by doing a mini proof again to kind of show you where it comes from. Okay, so we're starting with this triangle ABC, and we drew in here this height, by which we labeled H. Now, if B is this entire side, and when I draw in this altitude or this height, I call this right-hand portion just X. Well, then what would be left over here? Well, if b is the whole thing and I subtract out x, what would be left over here is b minus x. So keep that in mind here. And once again, this is kind of just like a proof of where it comes from. Okay, so the first thing I'm going to do is I'm going to look at just this right triangle. Okay, so if you look at this, if I would set up Pythagorean theorem, I would say that x squared plus h squared equals a squared. Okay, now also from that same triangle, okay, I'm going to say cosine of angle C is equal to x over a. Okay. Now, what I'm going to do here is I'm going to solve this for x. So I'm going to multiply the a over. So I'm going to have that x equals a cosine of angle C. So we're going to use these in a minute. Okay, so I'm going to switch gears here for a second. And I'm now going to look at the right triangle that's on the left-hand side. So if I would do Pythagorean theorem with that one, I would say, okay, h squared plus b minus x squared is equal to c squared. Okay, these guys squared equals that guy squared. Now, if I elaborate a little bit and I FOIL this guy out. Now remember, when you FOIL it, don't just tell me it's b squared plus x squared. You would write it out and multiply the whole thing together, and you would get b squared minus bx minus another bx technically. So let's say minus 2bx, and then plus x squared. Okay. Now, whoever came up with this, crazy mathematicians, they kind of worked until they found pieces that fit. Okay. So if we look here, notice I have an h squared plus an x squared. Well, here I have an h squared plus an x squared. So I'm going to replace those two pieces with this a squared. So now I have a squared plus b squared minus 2bx equals c squared. So ultimately, my goal here is going to be to get an equation that just uses pieces from the original right triangle, or excuse me, it doesn't have to be right, excuse me, from the original big triangle with just sides A, B, C, and just angles A, B, C before I put this height in. Okay? So ideally, I want to get this x out then. Well, if you notice, we solved this for x already. So let's replace that x with a cosine C. So when I rewrite this, or I rearrange this to make this prettier, the law of cosines is c squared equals a squared plus b squared minus 2ab cosine c. Okay? Now the key thing, all I did here is I switched the a and b and put the c squared on the other side. The key thing that you need to be aware of, though, is if this is side C, the piece that's isolated over here, this needs to be angle C. So if I would rearrange this, and once you take this further in like calc and stuff like that, we could have said, by all means, we could have said a squared. But now if you do that, this needs to be c squared plus b squared minus 2bc cosine of a. Oh, I need one more c here. Okay, so the key thing is that whatever side is here, this angle needs to be here. So if I switch it and I put A here, this needs to be angle A, and I can replace these so that these are B and C now. You could redo it with the B by itself as well. Most of the time you'll see it written like this, though, with the C by itself. Okay, so let's try some problems here. So the key thing, sorry, I should have said this from the very, very beginning, my bad, is you want to use this if given side, 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 or side, angle, side in a triangle. So if we think back, we used law of sines initially, okay, when we were given two angles and a side, so ASA or AAS. And then we went into the ambiguous case when we were given two sides and one angle opposite, so the ASS case. Okay, so we want to use, sorry, trying to jump back to my file. So we want to use this one when we're given 3 sides, side, 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 or 2 sides and an angle that's in between those sides. So you're not given an angle that's across from one of those sides. Sorry, I should have said that initially. My bad. So it says solve triangle ABC if A is 33, 46, 24. So here we're given side, side, side. So we're good to go. We should use law of cosines here. So the key thing here is we want to find the largest angle first, always. And I can elaborate on that in office hours Thursday. Okay, so I'm just going to draw a rough sketch here. It is not going to be to scale at all. Please make sure that you label these appropriately. So angle B should be a side or across from side B, C across from that angle. Okay, so I have side, side, side. So now, in this one, think about this. If I want to find the largest angle first, which angle should I be finding first? Hopefully you said angle B because the largest angle is across from the largest side. So kind of like I was saying above, we want B squared by itself here because we want to find angle B. So we need the cosine B here so we can find that angle. Okay, so I'm going to rearrange this. So B squared is by itself. Instead of A and B here, I'm going to have A and C. I'm going to bring this closer. Okay, because I want to find that angle B. So let's fill in. Well, I know B is 46, so 46 squared equals 33 squared plus 24 squared minus 2 times 33 times 24, and then we can find cosine of B. Okay? You have to be very, very careful with how you enter this calculator. So I would definitely at some point push pause and make sure you're entering this in right. So what you should do is, first of all, subtract these two over to the other side. So let's take, let me grab my calculator. Let's take 46 squared and subtract 33 squared and subtract 24 squared. So when I subtracted those over, I had 451 equals negative 2 times 33 times 24 cosine. Now I need to divide it by whatever this piece multiplied together. If it's being multiplied by cosine B, I want to take 451 and divide it by negative 2 times 33 times 24. So I got negative 0.284 something, 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 something. Right? That equals cosine B. So now let's do cosine inverse of that number, and I'm just going to use the long string that I got from my calculator, and I get that angle B is 106.53. Okay? Now, from there, once I have that angle, okay, I really just need to find one of the other angles, and then I can subtract from 180 to find the third. Sorry, I didn't point to appropriate places. So now I can use law of sines. Because now I have an angle across from a side. So I can say sine of 106.5, so that's angle B, so it should be over 46, equals sine of A over 33. You totally could have done sine of C over 24. It doesn't matter, pick one. So when you cross multiply and solve that, you should get that angle A is 43.5 degrees. I would take a minute and just make sure you're entering all of this in your calculator correctly. From there, subtract from 180 and angle C is 30 degrees. Okay, let's try another one. So notice here you're given two sides and an angle, but notice that angle is not across from either of those because that's A and B and that's C. So this is going to be our side angle side case. So once again, rough sketch, not to scale at all. Okay, this would be 18. Okay, so notice you don't have a pair that lines up so you can do the law of sines. Because remember, law of sines is sine of A over side A. You don't have that. So I'm going to find side C first here. Okay, so you can't do Pythagorean theorem because it's not a right triangle. So if I'm looking for side C, I'm going to use the law of cosines where C is solved by itself. So C squared equals A squared plus B squared minus 2AB cosine of C. Notice if this is A and B, these are A and B. If this is B and C, this is B and C. If this is C, this is C. Okay, so let's start to fill in. A is 18, so 18 squared, 34 squared, 18, 34, and now I know that angle C is 42 degrees. You can legitimately type this whole string in the calculator at once. So you can type in, and I'll do it right now just to double check, 18 squared plus 34 squared minus 2 times 18 times 34 times cosine of 42. Make sure you're in degree mode because that is in degrees. Okay, and I got that c squared equals 570.39. So let's square root that, and you should get that c is 20. Oops. And maybe just type that in to make sure that you get the same thing. So 23 point, it's 88, so I'll just do 0.9. Okay? So to fully solve a triangle, I need all sides and all angles. So from here, I can, once I have a side and angle, now I can use law of sines. Oops. Okay. So sine of 42 over 23.9 equals sine of, it doesn't matter if you do A or B, just pick one. So sine of A over 18. Okay, when you cross multiply, actually, I lied there. Sorry. Total side note. You want to find the, oh my goodness, smallest angle first. And it must be acute. And I will elaborate on that more in office hours on Thursday also. Okay, so when you cross multiply and solve, you should get that angle A is 30.3 degrees. From there, you can subtract from 180, the angle B is 107. Okay? From here, you're going to do a couple practice problems on this. There's just 4 of them. Okay? And the key is included for that. I will have more practice after we do the law of sines quiz and stuff provided on Friday for all of that. So please touch base if you need any help at all. I hope you guys are doing well.